Hello everyone. In this video we're going to be solving a logarithmic, exponential, logarithmic, whatever we want to call this type of equation. We have x to the power log x equals 10 to the power 2025. Obviously 10 to the power 2025 is a very large number, 1 followed by 2025 zeros. So I'm going to be presenting two methods for this problem. You've probably seen this problem before. I'm pretty sure you've seen a similar problem, and this is kind of easy. I know some people are going to complain that, this is too easy, I can do it with my eyes closed, but it illustrates a couple important strategies and points we use for solving these kinds of equations. Anyways, let's get started with the first method. So, my first method involves logging both sides, obviously. Whenever you see an exponential equation, you can log both sides. Especially in this kind of situation, it works real well because you'll see in a little bit. If I log both sides, of course, log here means like log x means log x base 10. That's what I mean, not the natural logarithm, because otherwise I would just write ln x. That will be base e. All right, let's make sure we're clear on that one. So logging both sides base 10 is going to give us the following: log x to the power log x equals log 10 to the power 2025. Now, as you know from rules of logarithms, or at least you should know if you're studying logarithms, if you're not studying logarithms, if you haven't studied them before, I highly recommend that you look at it, because if you know something about exponentials, then logs are very easy to learn. There's a basic definition which you can pretty much apply to any situation. And we're actually going to talk about that in the second method. So, this log x is the power of x. Therefore, I can move it to the front. So it looks like this: log x multiplied by log x. And the same thing goes here. You can move the 2025 and make it a coefficient. This is the beautiful thing about logs, that you can kind of turn it into something more linear as opposed to exponential. And then multiply by log 10. Of course, log 10 is equal to 1, so I don't even have to write it. I just wanted to show my work so that the teacher doesn't take off points. All right, great. So now on the left-hand side, we have log x multiplied by itself. What is that supposed to mean? It means you are squaring that quantity. Well, on the right-hand side, I have 1 times a number, which means it's the same number, 2025. The reason why I picked 2025 is because it's coming up in about 4 years, right? Well, not only that, it's kind of relevant to hopefully in 4 years things are going to be much better. You know, we're going to live in a better world, but so on and so forth. But that's not the only reason, of course. The second reason is 2025 is a perfect square. How do I know that? Because 4 times 5 is equal to 20. You just attach the 25, and that gives you 45 squared. Okay, so briefly, let's talk about some shortcuts here, even though we could make a separate video on this, but I just wanted to mention this. So I digress a little bit. Allow me to do it. So if you have consider a 2-digit number that ends in 5, like 35. If you're trying to square this, there's a shortcut. You've probably seen this, maybe some of you have seen it before, but it's really cool. I'm looking at the tens digit, which is a 3. What is 1 more than 3? 4. So you can do this mentally. It's kind of fun. You can kind of show off to other people, like, oh, I can multiply in my head. 3 times 4 equals 12, and then 5 squared is 25. You're done. Isn't that awesome? You can do this with the 45 squared. 4 times 5 is 20. Write the 20 and then just attach the 25. Let's try this with 75 squared. Is that going to work? Absolutely. 7 times 8 is equal to 56, and you can do this in like 3 seconds. Isn't that awesome? Yes, and of course there are other shortcuts which we can talk about, but let's get back to this. So my point was to kind of illustrate that I know 2025 is 45 squared. Great. So this gives us two solutions. Log x could be, square root of this, absolute value stuff, so on and so forth. So log x is either 45 or log x is negative 45. Now, some people may complain saying that you can't have negatives with logs. Yes, you can. The log of something can be negative, but you can't log a negative. So that's the difference. What is this supposed to mean? Well, if log x is equal to 45, this just means by the definition of logs, remember, I was telling you that it's super duper important. The base is 10, so this means that x is equal to 10 to the power 45, again, which is a large number, not as bad as the original number. and this means x is equal to 10 to the power negative 45. Obviously, this is a very, very small number. So we get two solutions from here, and this brings us to the end of, not the video, but the first method. So let's go ahead and talk about the second method. All right, here's my second method. The second method, let me write the equation one more time. It was x to the power log x equals 10 to the power 2025. Okay, now if you know the definition of logs, this method you will probably like better, and let me know which method you like better, of course. Now, you see this expression log x, I don't really like that. I'm just going to call that something. How about calling log x y? And you know why, because I like substitution. That's why I want to use y. So if log x is equal to y from here, using the definition of log, remember the base is 10, x becomes 10 to the power y. Great. So now I can replace x with 10 to the power y, and I can replace log x with y, and things are going to get better. Let's see how this works. So I'm going to replace x with 10 to the power y, not y. X will be replaced with 10 to the power y, and the exponent log x will be replaced with y, and the right hand side is going to stay the same. Great. Now I got rid of the log. Isn't that beautiful? If you don't like logs, you can get rid of logs by using substitution. But of course, you have to use the definition just once. Now this gives me the power of a power, which makes it even more powerful. I get 10 to the power y squared equals 10 to the power 2025. This is something we should be familiar with, because this is an exponential equation and the bases are equal. So the exponents must also be equal. Since the base is not 1, this is not always going to work. It's only going to work for certain values of y. And those values are going to be the same y values we found before. Y squared equals 2025. If you square root both sides, you get the absolute value of y is equal to 2025 square rooted. And this means that the absolute value of y is equal to 45. And this means y is 45 or y is negative 45. But remember, we are not trying to solve for y, we're solving for x. Y is kind of like what is called a dummy variable, and I have to back substitute. So log x is equal to y. This means log x is equal to 45, and this implies x is equal to 10 to the power 45, just like before. Or log x is equal to negative 45, and this implies x is equal to 10 to the power negative 45, which you can also write as 1 over 10 to the power 45, which is a very, 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 very small, very, very small number. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.